All right, in this video, we are going to talk about simple random sampling. So, if you have to conduct a study of your own, right, and so you'll be collecting information from some population or some other source. So, the information that you need might come from using information from a previous study, right? So maybe somebody else published a study on a population that you are concerned with, and you can use their data that they provide to study some other aspect of the population. So maybe somebody is studying, some type of animal, like say bears or something like that, and they go out and they have all this, study this information from bears in their study. So they go out and they measure, how tall the bears are and other characteristics, and maybe they provide information that was helpful in your study. So you can use data from a previous study. Then the next way that you could get data from a population is through what's called a census, right? And a census is going around to every individual in the entire population. All right, and so that's a huge undertaking if you have a large population, right? You may have heard of the term census in terms of the U.S. United States Census, right? That's done every 10 years, and it was supposed to be going on this year, right? So in 2020, and every 10 years. So basically, what they try to do is they try to get information from the entire population, go out to everybody in the whole United States and collect information. All right, so that's a census when you take information from the entire population. All right, next up is sampling, and that is when you obtain information from a subset of the entire population. So not everybody, you just go out and you take information from some of the individuals in the population that you're studying. And so, as you can imagine, that's a lot easier generally than a census, right? But you're going to get some variation in the samples when you do that. So you have to, learn how to account for that. Uh, and then finally, experimentation, when you design and conduct an experiment, okay, to maybe help determine if one factor causes another. Okay, so all right, so whenever you take a sample, right, then the sample should be representative. It should reflect as closely as possible the relevant characteristics that you're considering. Okay, so for instance, I'll use the example again. If you want to know, hey, what's the average height of American citizens these days, or the people living in America, right? Then you could go out, right, and take a sample. You go knock on doors and find um, people willing to give you their height, and then see what the average is. Okay, and so again, if you went and only talked to people who were basketball players in the NBA, right, at that level, the height of the players in the NBA is pretty high, right? If you've ever been to an NBA game and like, sat up close, then you start realizing, wow, those guys are tall individuals. So if you took that to be your representative sample, that really is not going to reflect the average height of all Americans. So when you take the sample, your sample should be representative. All right. And most modern sampling techniques involve the use of probability sampling. And what that means is you use some kind of random device to decide which members of the population will constitute the sample. All right, and so that's very, very important that you try to do that. And so that brings us to the concept of simple random sampling. All right, and what simple random sampling is a sampling procedure in which every possible sample of a given size is equally likely to be the one that you obtain. So everything has the same chance, right? Every group that you sample every possible group has the same chance of being the one that's picked. Okay. And when you design experiments, it's incredibly important that you that you sample in a way like this. Okay. Otherwise, the results that you get are not going to be reflective, right, of the population, and your results will be you'll waste a lot of time and energy because people are going to say, I can't trust these results that you have because it wasn't obtained through a simple random sample. Okay. There are two types. There's simple random sampling with replacement, and that is when you sample and then each member of the population can be selected more than once. All right. And then there is simple random sampling without replacement, and that's where each member of the population can be selected at most once. And that's sort of the default one that we're going to assume. Unless otherwise specified, right, we will always assume that simple random sampling is done without replacement. So each person can be picked, or each individual in the population can be picked at most once. Okay. And we'll, again, use that most of the time. And in fact, all but one part of this course where we'll talk about sampling with replacement. Okay, so on these slides for fall 2020, we are just going to skip these questions here. It's not like they are not important. Okay. This just kind of procedure shows you how to use the number table in the back of our book to select simple random samples. All right, and like I said, not like it's not important, but just to save a little time, we are going to skip through that this semester. There's the answer. All right, and just going to skip through here as well. All right. And so you do not have to do these homework problems because they involve those examples that we just skipped. So just wanted to talk about simple random sampling and how it's done, because it's a very important underlying thing that you have to do when you're talking about these type of experiments. And most of the situations that we talk about will assume that the data was collected by doing simple random samples.